Okay. Good afternoon.
Good afternoon, sir.
Yeah. Okay. So, how's your makeup exam? Yes, last week makeup exam was there, right? Anybody gave makeup exam?
Yes, sir, I have given any makeup.
Yes, sir.
Okay. How's the exam?
That was very good.
Good. Easy? Easy, medium, difficult
Sir,
in
it was
terms
easy.
Medium.
easy. Medium.
Medium, medium.
Okay. Not tough, right? All expected. Hmm. Good. Not much of portion is there, right? So okay, now I hope everyone would have studied the mid exam till whatever we have covered till mid exam. So now I think you will be eligible to give a real like feedback on how the content is, how the content was till now. So is it useful or you expected something else? Don't tell me agentic, that is part of the second one. I'm talking about for the basics.
Hi, sir.
So yeah,
Hello. Am I audible?
yeah, 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 you're
Yeah,
audible.
sir. Yeah, I think your content is very good, sir, and especially the details that you help to understand in all the topics like from LoRa, QLoRa to SFT and all that. It's very good.
Mm, mm.
What one thing which we can look at is, can we take it as a constructive uh, project during the course? Let's say we start with the basic LLM, then start with SFT, go through the course of SFT, then let's add LoRa for it, and then we will add React to it, right? So that it will be end of the sessions, we will have a complete end-to-end code for a project. Like maybe it can be one single use case or multiple use cases we can take up by ourselves.
No, it cannot be done like that. We cannot teach React here. It is not logical here. This is a conversational AI course, right? So it's not like you have to build a front end and all those things. Extra stuffs are required. See, there is a difference between building you are in a project or here. So I'm I'm myself an engineering manager. Okay, we follow all PRAs, SDLC, everything. So we cannot teach that here. Yeah, you can teach if you come to my team. I will teach you there. But here it is not possible, right? Because that see, I'll tell you what all you have to add on to what we are learning here. That I can tell you. You have to read it elsewhere or the other course or otherwise you have to learn. So first thing is how to go to production, right? So first thing is you have to learn about the infrastructure. So how do you manage the infrastructure? That's not part of here. Okay. So manage means how do you what infrastructure is required. So that makes a huge difference. Okay. So because the coding process itself will change because of the infrastructure setup. Okay. So it's not just applying techniques. Applying techniques, yes, you should know all the techniques. That's the Gen A expertise point. If you do not know what to do, even if you know great amount of infrastructure, that doesn't help, right? Infrastructure is something like you have a lot of utensils, costly utensils, or a lot of utensils in your kitchen. But if you do not know how to cook, there is no use, right? So cooking is your Gen A expertise, which we will teach. But after that, you need utensils to cook, right? So those things are required. After that, you should have a what do you call the front end part. So front end is not a big deal. Front end, it doesn't apply for every project also. So some project you will use your own front end. Some projects you can do it as a microservice, right? So that also, but you should learn that. But nowadays there are a lot of this AI coding things, you can use it to build on, and then you can test it. So you can use either you can build it on React or whatever it is, whatever you are comfortable with. So that you have to learn. That we cannot teach. Okay. So we cannot teach me. I can teach, but it is not part of this course. Okay. So there are a lot of more things to learn in this course. If you want me to teach all those things, we have to change the name of the subject for course first of all. And if we teach all those things, you will miss out the core. See, if you see, what I talked about was like you take kitchen only. Cooking you can teach for 3 years, right? You ask anybody who starts cooking, can they learn it in this 4 months? No, it's not possible. You can learn few things, but there are a lot of techniques coming up. So those I am talking about, if you have some points on those things, we can learn, we can teach, we can add on. But if you ask me like the complete project, no, it's not possible. I am telling you, cooking itself, you cannot learn it in 4 months. How can we learn what utensils to purchase? Like you are asking, like a grandma who knows what is the utensils to be useful in your home, right? That experience is required that much, right? So that is a data engineering part. And there is one more thing called as LLM ops or ML ops, right? That is also not here. So few things I have mentioned based on, because I cannot restrict because I have done work on everywhere, all these places. So I tell some things where there is a overlaps, right? So, but if you want to really learn a good ML ops, then you should take a separate course on it, right? ML ops or
Oh,
LLM ops,
sir,
right? That
sorry to
requires.
interrupt you, sir.
Yeah, yeah.
So the idea is to just learn the training pipeline for LLMs. That's all.
Yeah, you can learn it from your, say, training pipeline. What is training pipeline? If you know to train, you can build the other part, right? So if, see, first of all, a team is required for building a project, what you are asking for, right? So if you are building a POC, it's useless. I tell you, it's completely useless. Why I'm telling you, I have seen thousands of people have built POCs on RAG. Like for example, last semester we gave RAG, right? So do you think everybody built one RAG system? Do you think everybody qualifies to become a data scientist or Gen AI scientist? No, zero. That is not a qualification at all, right? POCs nowadays, 12th standard guys does it. Like I teach here, in my not teach, just mentor them. They are just second year college, BTech. They are doing better jobs in RAG, but that doesn't qualify for them. That's fine. Okay, something comes out is fine, but when you want to go for production grade, a lot of work is going to be like we have to do, right? So end to end matlab kya hai? Like I understand, I don't understand end to end matlab. For me it's a project is end to end, right? We take at least 4 months to do it with six people and two DevOps guys, two Cloud Ops guys, right? Apart from these six people. So it becomes a very huge project. It's not possible to build at all in this course. That is what I'm talking about, production grade. And if you're talking about a POCs, like POCs, like you make one Streamlit or some what do you call this, front end or something, this React and stuff. That's simple, right? If you want to have a POCs type, that should be a simple thing. You can build it if you sit on a weekend. What like is it? Did I answer your question, or
Yeah. So
I
no,
just
actually,
rejected
React, I
it?
think it got confused here, but React was I was looking for reasoning and action loop that we learned, right?
Okay.
Oh, so
Okay, okay.
not
Oh,
the
I thought
front part, right?
React JS, that one.
No.
Okay, okay.
Yeah, okay, okay,
Oh,
fine, sir.
React
Yeah,
you are talking. React though
yeah.
you already have, right? Okay, you wanted to apply it. You want to apply
Yes,
in a
and
project, right?
any code
Okay,
snippets like how to like
okay.
let's say for Laura, if we have to
Yeah, yeah, I
create
got your point. I'll
the
answer you. I'll
instructions in
answer you. I
yeah.
understood you. See, I'll tell you one thing. In our second assignment, right? So that is what is given actually. So it will look like simple, but point is the options are given. Okay. So options means, See, one more thing I'll tell you. The second assignment, it will be like option. If you want, you take two choices, two techniques out of this, and then apply it in your project. Because we have to consider every each one of your team members, right? So we cannot say that okay, build something very robust with all the techniques which you have learned till now. Yes, it's possible to build, but we cannot compel you guys to do it. Okay. So what we do, we give some 10 techniques, or maybe segregated category. Category A will be four techniques, category B will be four techniques, category C will be four techniques. So we'll tell individually take two techniques from category A, category B, and category C. Okay. So what I'm trying to say here is, if you see, all the techniques what you learned will be there in that. So my point is, if you wanted to learn, apply every technique and submit the assignment.
Sure, sir.
So
Yeah,
now
got
you
it.
ask me how to apply every technique. Don't tell me, okay, sir, one technique applied, how can I apply? No, you can apply that. So you have to put an intent recognizer in the start. Like for example, for one kind of questions, one technique will work. Okay. For another kind of question, another route you have to take. So that you have to intelligently add it in the front of the technique, so that you have all the four techniques either in parallel, or two in parallel and third and fourth in sequence, something like that. You have to understand the logic and what is the, and if we give some 10 PDF documents, you take 100 PDF documents for your learning. So it becomes a good. So we'll never say no to if you take 100 documents, right? So we'll, but inside that 100 document, this 10 documents what we give should be there. But you can take 100 documents and do the same thing. Okay, so like that you have to put your extra effort, because we cannot compel everybody to work on 100 documents and all the techniques. Then they will come up and say it's a you're expecting so much. Say there are people out there, right? Hope you understand that part. So we
Sure,
have to
sure.
be in average to everyone, and whoever wants to learn more can obviously put in their extra thing and then submit. But that's being said, I'll not guarantee that okay, you put all the techniques and you expect more marks. No, 10 is the maximum. Who applied two techniques also will get 10. Okay. So if you want that marks, you should not be a consideration when you are going for learning. Okay. Yeah, Pavan.
Yeah. So one question I had, like in the same context, I am trying
Mm-hmm.
to implement some orchestration using the React reasoning plus acting agent, and I'm using the LangGraph, which basically, sorry, LangChain, which basically provides the React fundamental implementation. So, are there any drawbacks using LangChain framework for production grade application? Because definitely long down the line, I want to take it to production as well. Any feedback from your side?
Okay. See, for personally, see, it is my personal choice. I'll not say that is uh, mm, tested robustly to give you this decision. I would personally not go for LangGraph. Okay. So, and not only LangGraph, any of the frameworks. I will prefer to use basic Python to write everything for production. For production. For POCs, yes, you can use a land graph or anything. For productions, no. If you write in land graph,
Also,
in fact, I will ask this
also
question
if
if
the
you would
end
have.
user,
Uh,
sorry, just wanted to
yeah.
add one more context. Also, if the end user is not, external customer, like
Okay.
internal our team also. For example,
Mm-hmm.
an agent-based application to automate some data engineering small works, right? So if that
Mm-hmm.
is the use case, end user is not external customer, even in that case,
Mm.
we should do the basic Python, because that brings in lots of heavy loading of implementing the foundational orchestration, right?
Yes, yes, yes. No, whatever you want to get, go to production. A production means full-fledged who is going to pay you, right? So either to your inside your company or outside your company, whoever is going to pay you, it's a robust one which will be scalable. Is only option is to write basic Python code. So if you go for frameworks, you will pay it. Pay it means it will become very complicated that it's very difficult to manage. And fine control is not possible. This the most important thing is the fine control. So that's not possible. You have to trust on what is there at the back end. Or if you are very good at understanding their classes, right? So land graphs classes, and then tweaking those library files. I don't prefer that. I better prefer because I reading others' code and changing that is more difficult than writing my own code. So I
Okay.
prefer to write my own code. So that is the point. So that's the point. Fine control is not
Yeah,
possible, and also it is very heavy. The libraries, the frameworks, I'll not call it by name, but there are some frameworks which are very heavy. So, but for the functionality, what we use, that much is not required at single point of time. So it's not
yeah,
like loading that much big for small works, right? So we do a sequence of work. Our sequence and parallelization matters for us rather than using some high-end stuff, right? It's
I understand, sir.
in
So
layman's
I think
term.
I
Yeah,
got my
yeah.
answer. Yeah. So
Okay.
probably what you are suggesting is for an MVP, probably go for
Quick ones. Yeah.
like platforms, yeah, platforms or
Hmm.
frameworks because they are faster to implement it. But then if you want to
Correct.
implement full-fledged application, better go for
Hmm.
native coding. Okay,
Correct. Correct. Yep.
got it. Thank you, sir.
Thank you. Yeah. So let's go into the course. Yeah. So how's okay? All questions answered. I guess there was a question I missed. Assignment one is not graded. Oops. ज़्यादा ही हो गया. Vedash Jela. Okay, I'll. Can you
Sir,
send an
I've
email?
also emailed you, sir. Already emailed you last week itself, but I haven't
Oh, okay. Okay,
got any
okay.
response
No, I
from you.
didn't see any emails. Too much busy in office.
Okay.
Okay, I'll check. So don't worry.
Yet.
For you also, lot of people.
Yes,
How
there are many
come?
people left.
Oops.
A lot of
Okay,
people
all
have
of
left.
them. Can you do one thing? I'll prepare one Excel sheet and share it. You can fill your email IDs there. Just 1 minute. It becomes very difficult. How come it got missed? Uh, this is. uh, I'll share one Excel sheet. Okay, so just put that your names in there so that I'll follow up my drive. Create one. What do you create? Okay, new file, right? New file, Google Sheets. Okay. Mm, so assignment one, pending evaluation. Okay. Mm, what is your this email ID? It's called as email IDs, right? Your employee numbers or your student IDs. It's email ID or different?
It's
Same,
email
right?
ID only.
Email ID
Yes.
only. Okay, I'm just giving that. Okay, share with others. Okay, so okay, I've tried the conversation A course. Okay, I'll share the link. Let me know if you can see this. Just anyone, just open and can you access that? Yeah, I guess somebody accessed. Okay, yeah, it's fine. Okay, thanks. Okay, so just tell everyone to put their, don't put your email IDs who wanted more marks. Okay, so it's not for that mark. If you have not at all got evaluated, then only you put. Okay, quiz 2. Yes, quiz 2 will be there on 11th. Okay. Okay, chalo, we'll go into the
What,
today's
Bhagath sir, what
lecture.
you share the Nexus sheet?
It's view only, sir. It's not editable.
Oh, ऐसे क्या? Okay. अरे, read the topic ना. Somebody asked for share. Okay, viewer, editor. I should change. Now check. Actually, was. Okay. Okay, coming back to the um, this lecture. So what we saw last class was basic RAG architecture. Okay. Our topics for quiz 2 will be whatever we covered the last 2 lectures, most probably. Okay. Today lecture and last class. And maybe I'll not restrict till here. So consider okay, let's only keep these two. Uh, or consider everything after quiz 1. Okay, that is more little bit content will be more. Here it will be like very less. Okay, just consider whatever was there after quiz 1. So most probably you would have studied already, right? So for mid exam, only these two lectures you should concentrate. Okay, let's go into the lecture. We have to complete it. Okay, so document processing. So we saw the RAG, right? So RAG includes a lot of steps. So the top one is the top line is the indexing pipeline, wherein you take the documents, do a chunking. Okay, there are different types of chunking. We'll see some of them. And then you create the embeddings. Okay, and then you put it in the vector DB. So again, there are a lot of variety, like ways in which you can create embedding. That also we'll discuss. But in this course, we have kept only text embeddings. We can have other embeddings also. Okay, and then we can put it in the vector DB. And then that is the top indexing pipeline. And the next pipeline is the query time pipeline. Okay, in query time pipeline, when a user asks a query, so it goes for a retrieval. So it's a very simplest RAG return. So it's goes for a retrieval, gets that context, okay, whatever is retrieved, and the original query is also added. Okay, this one. The original query is also added, and then you create the LLM response and then stream it to the front end, okay, to the user. That's a very simple RAG. Everybody knows that's it. So we'll see some chunking techniques. More than here, see, there are some chunking techniques. So this is fixed size chunking. Chunking means you set one, what do you call this, a limit. Okay. So we normally, we can set the limit based on tokens. That is most ideal way. Okay. You have to, uh, this is, if you are taking fixed chunking, you have to take it by token wise. Okay. The number of tokens. So because LLMs understand tokens only, it doesn't understand words. Okay. I hope you all know what is the difference between a token and a word. That much is required. Okay. So uh, and else you can take it by character also, but this is not preferred. Preferred is mostly tokens because LLM understands by tokens. Okay, that is why. And LLMs, the token limit, there will be a context window. Context window of LLM is defined by the uh, tokens only, the number of tokens. So it's better to use tokens here. Okay. And the pros cons you can read. So the uniform documents. What do we mean uniform documents is? So here, what I try to mean here is that it is more of a all the formats, all the documents in your repository, like you want to embed some 1,000 documents, right? So you want to do the query on the 1,000 documents. All the 1,000 documents are uniform. It's not like size is uniform. We are talking about it is all a particular set of, like for example, mm, a particular type, maybe a drilling report. Drilling report is a particular type, right? So all 1,000 are drilling report. But for example, uh, if there is a mixed type, then you have to understand that by the meaning of the sections, right? So your sections will change. But uniform documents means in this, so drilling report will have, okay, first section will be something, second section will be something. But in this case, there will be variable sizes as well as contents also will be different. So one can be drilling report, another can be some other report, right? Or it can be an MOM, you know. So meeting MOMs, right? And another can be something like summaries, like project summaries or annual reports, right? So like this different sets of documents. So in that case, you have a different type meanings. So in that case, you wanted to extract the extract means you have to mm, bring chunks in some meaningful way. So that is why we will go for a semantic chunking. Semantic chunking means you understand that, okay, there is a difference between like so you use a cosine similarity. Okay. So you take a sentence. So there are some four sentences belonging to one topic, and there are four sentences belonging to other topic. So if you take cosine similarity between these two sentences, it will be very close. So at least maybe 6.6.7. But if you take a cosine similarity between this line and this line, it will be very, very low, right? So maybe 3, 2, like that, zero point 0.2, zero point 0.3. So in this case, you have to cut this as chunk 1 and this as chunk 2. Okay. So that is how it is done. Okay. So create a new chunk. So when the here they are giving a threshold of 0.7. You can have any limit. Okay. So it depends on exactly. That's why in nothing in LLM or GenAI or data science is constant, right? So it again depends on your use case. So today you start with zero point 0.7. Tomorrow you can you may think, okay, based on chunking strategy, you may feel okay, zero point 0.5 is a threshold. Okay. So keep that in mind. And third one is the recursive chunking. Okay. Recursive chunking means hierarchical splitting. Okay. So you will have like this first level is headers, second level is paragraph, third is sentences, fourth is characters. So you have to have a structure. So recursive chunking, when we will do is we can also hmm, we can also create so if there are a lot of documents, right? So then also we can go for a recursive chunking. So it's not only just structured documents, lot of documents. So in that case, it is not mandatory you have to go for like 1, 2, 3, and 4 hierarchy. You can take it as two hierarchies also. Like in one of my project I have done. So if you say like document is first level, not exactly document summary. This is like base level 0. Okay, first level will be like sections. Okay, next will be paragraphs. So this is also one kind of hierarchical chunking window. Okay, so this also easy so that you don't you can reduce the number of search spaces very easily. So already your vectors will use HLSW, right? So HLSW. Okay, so this one it will do the same logic you are applying for the uh, vector database also. This is one database, this is second database, this is third database. Database means tables. Okay, so there are more chunking methodology also. We can see anybody. I think many of you would have worked on it. So, can you think of any other chunking techniques? So, two questions I wanted to ask here. One is any other chunking technique? Second one, uh, tell me a scenario. Okay, tell me a scenario where where the above three, I will write three only, three fails. Anybody wants to answer any of the or both of the questions?
So hierarchical chunking is another method.
You can consider it as another method because recursive they strictly do like this. Uh, you tell me a scenario where leave a hierarchical chunking. Any other chunking method?
So one
Sir,
could be
chronological way.
overlapping. Basically, here you are dividing into certain chunks and
Hmm.
you want to
Okay,
overlap between, so
overlapping.
that understanding is there between the two.
No, no, overlapping will be there in everywhere. This not everywhere. This in this case for sure overlapping will be there. Plus overlap. Okay. So we don't cut exactly and then leave it. Fixed chunking means with overlap only. So if your document
Uh,
is suppose this much length, so this is chunk one. Chunk two will be from here to here. This is chunk two. Chunk three will have overlap of like this. You understand, right? So this is chunk two. So chunk two has a overlap of with chunk three and chunk one. So like this. So by default overlap will be there. Overlap is not a separate way of chunking. It's just a number you have to add it. Now sliding window type, right? In your CNN you would have it. So any other specific, so I'm more interested on the second question. Okay, anybody wants to answer something else?
Chronological way of chunking. Like I mean,
That's what I was
ar-
talking about as hierarchical. Like here, document, section, and paragraph.
The second one fail in the context, like when there's a long sequence trying to fetch the data, you don't get the semantic meaning of the retrieval.
Second one.
Yeah.
Mm, okay. Yeah, great. Any. Think out of the box. Actually, I'm making you guys biased actually here. In fact, this complete slide deck itself is biased on something which I already mentioned here.
Based on the
At this
structure of
point,
the
I mentioned.
document, we can
I
have
mentioned
a
it
chunking.
just when I was explaining embody. If you
Maybe
guys
sir, for
remember it.
image data it will fail. I guess.
Very good. Paisa. Kaun hai? You listened very carefully. Very good. Good. Yeah. So for image, yeah, tell me where you will fail. You will fail when there are images, but why? Why it will fail? When a document, suppose you take a PDF, right? There are images. For example, where are the images? Everything is image actually. Okay. Suppose this is an image, okay, instead of a text.
Hello.
Say hello.
Yeah. Sorry, sir.
Okay.
I was just checking whether I was audible.
Oh, okay. No. So this is an image, right? So if you extract this as a text, for example, even this letters are these words are readable. Okay. OCR you used. Okay, you read it. All this fine. But will it make sense? Because when you extract this in a text file, right? So what it will become? It will become user query documents in one line. Second line, it may come like indexing, naive rag, advanced track. Third line, it will come indexing, query retrieval, indexing. Fourth line, the query routing. Fifth line, this one. Sixth line, this one. Seventh line, this one, and this one. eighth line, this one, this one, this one, this one, this one. So it will not make sense, right? So in such a text, how will you understand there was a flow, right? So image go, you have to capture it as an image. Otherwise, you lose that what do you call the meaning of the words, right? So that's where all these chunkings will fail. So you have to handle images like in mostly in technical documents everywhere, like in my previous organization as well as the second current, everywhere it is same logic. So you take any technical documents, it will have images. So if you are not having images, you are lucky. Okay. So for example, a small thing I'll tell you, one of a very very small project which I did, help documentation. Okay, for a it's like the company's help requirements, right? So help documentation, there will be lot of screenshots, right? So there is a reason why that screenshots are there, right? So you cannot skip those screenshots. When a user asks a question, how to prepare a particular, what is the procedure to request for a IT ticket, for example. So in that help documentation, there will be like explanation steps, and then there will be screenshots, and then it will explain, okay, you go here, click this, right, that. And so those images really help them. If you don't provide that at the front end to the user, is it that is more poorer than they personally go to that documentation and then see that. Okay, the users may prefer doing that. So that's where these three will fail. And how will we do that is really not we are not going to cover here. But just one point, you have to handle the images. How will you handle? You think. Okay, so just think how you can handle. Another way, in a pure text document, also this may fail. What pure text document, not even scanned, a pure text document, it can fail. All the three chunks may not capture the correct thing. Can you tell a scenario?
So, like CSV files with distinct rows, and if you
CSV
want it
file.
with a
Yeah, yeah, yeah.
distinct rows, and then you want to do an aggregate queries. Let's suppose we have 250 rows with employee manager and employees, and you want to compare employees performance. But also it has employee managers reporting. So if you want to understand, if we chunk through at a row level, but like if you want to understand who is the manager of a person, then the aggregation LLM, doing that LLM, it might not return the exact queries. I mean, it might return few records, but yeah.
No, wait.
Multi-format data, like tabular data or any other format data is also included as part of the text document.
Yeah. It will be there. All the text readable documents, readable parts. Only thing what I discarded, you try to tell you not to consider is images and OCR. So any form of like document, Word document, may if you create without images, you can create text tables also, right? So those things you should consider. So coming back to the first person who was talking about the CSV or Excel format. So ideally you cannot chunk it. Okay. So first and foremost thing is you should not chunk those documents. If you chunk, you will never be able to get the answers. So how will you deal that Excel sheet is not, it's not easier, not belonging to this category at all. But I didn't want that question to be raised here. But how do you deal in a one single line? I can answer. You have to consider table as a table. Okay, so hope you understand that as a Python
Okay.
coders, right? So
Yeah.
then only you'll get the answer. Okay. So
Okay.
that answers that question. But second question, what I was trying to say here, like what I wanted you guys to think is, think of, okay, take a document like this. Okay, so this, very bad line. So this is a document. Okay, this is a document one. There is a paragraph, there is a title, there is a paragraph, for example, correct? And there is a follow paragraph. Okay. Then there is a follow paragraph. And this is page one, you can say. This is page one. So page two again will be like this, same thing, similar way. And there will be a follow paragraph. Maybe there is a title too. Okay. Maybe this is top document title is in the top. Okay. So this is subtitle. Subtitle one. This is subtitle two. Okay. This is document title. Okay. This part is document title and this is subtitle two. So you have like this. So what I'm trying to say here is like if you do a semantics chunking, so fixed chunking is so much problematic in a way. Like for example, this is one paragraph. Suppose this paragraph has suppose 1,000 tokens. Okay, so you will suppose I wanted to make it 400 at a time and a overlap of 100. So I will make 400 tokens first chunk one, and overlap means then from 300 to 700. Correct. Again 400 tokens chunk two, then 600 to 1000. The last 400 into chunk three. So I made it three chunks. Okay. So this is fixed chunking. In semantic chunking, again, you take, see, semantic chunking, what I said, you will get it in a complete section, right? So complete section, 1,000 tokens are there. Ideally, you may not be able to do that 1,000 chunks. Again, you have to split it into smaller one using fixed chunking. So you should use semantic with fixed. Okay, then only you will meet that one. You will do semantic so that you separate this paragraphs separately. Okay, this paragraph is one chunk. This is the first high level chunk you will prepare. But again, this is 1,000 tokens, right? So you cannot have 1,000 tokens. I'll tell you why. That we will. I think this is the slide. We'll talk about it. So there are 1,000 tokens. So again, you have to split that. So in fixed chunking, what happens? This 400 you blocked, and in this from here 100 will be overlap, and next 300 will be from here. Correct. So this will become chunk 4 in fixed chunking. Okay, you understand? So there will be a connection between these two. But in semantic chunking, what happens? You separate this one and this one completely, and then you will create one three chunks here, and from here again you will start 400 chunks. Okay, so there is not much of overlap. If you want to have overlap, you can have, but it is uh, you are having already a section difference, right, or paragraph difference. But what I'm trying to say here is what is missing. I was trying to say is that there is a topic being discussed in this paragraph, right? So in this paragraph, suppose you are talking about Bhagath. Okay, so you're talking about Bhagath in this paragraph, and in this paragraph, we will continue like, okay, he is living in Bangalore, maybe suppose. Okay, and in this paragraph, you are saying, okay, he studied in uh, uh, maybe okay, you studied in Delhi. Okay, suppose like this. And in this paragraph, this is a continuation, same subtitle, right? So he is maybe he's a family man. Okay, something like that. Okay. So what I'm trying to say is the chunk which will be prepared from here would be lost because as I told you, the chunk being prepared here, and then you will create embeddings here, right? Correct. From this chunk, you will create one embedding, correct? And then you will go for searching. But what is this? If a user asks a query, okay, uh, list people who are all a family man. Okay, suppose I ask this question as the in your chatbot. So it will correctly find this chunk because that family man word is here. Okay. But who is that? Who is the person? This chunk is not talking about Bhagat. It's talking about he. It's pronouns, right? So there is no, this is called entity resolution. Okay. This is called, there is two terms in graph technique. This is called entity resolution and entity alignments. Okay. So these two things helps in these kind of scenarios. Okay, so that's why I was talking about this out of syllabus, but I'm telling you, remember this concept. This concept will fail for surely you do any type of chunking. Okay, except hierarchical chunking, somewhat it will help. Okay, somewhat it will help, but in that you have to map it, not this hierarchical, this hierarchical. So that is why in some places we have deployed this hierarchical. What happens is when you have a document summary, so in document summary you can say, okay, this is talking about Bhagat. Okay, so in your paragraph it will be like he is a family man, right? So what happens is when your query comes in, you search the document which is okay. Bhagat is there. Okay, you don't search like this. Sorry, you search ulta. Okay, you search here. Okay, so you search the low level paragraphs. Okay, you get it, and then you will also combine the section detail as well as the document summary, and all these things you will take it to LLM. Okay, so what happens is your query searched family man, but in this chunk there is no detail about who is that family man, right? But when it goes to section, still it may not be. But in document summary, it will be surely there, right? So it would have had the details. Either here or here, that details will be there. So it will be able to capture. The LLM will be able to capture, okay, Bhagat is the family man. Okay. So this is, but it is not 100% like graph, but it will work till 75% of the time. So I'll not say that this will be 100%, but most of the time. It again depends on what kind of documents you have. Okay. Co-reference. Yeah, that is also there. So entity resolution alignment, you don't need to learn. This is just for uh, information. But this hierarchical chunking will help in which will not be possible by these three chunks. So my question will not be in exam. I'll not make you to explain this. I'll ask you a scenario where it will fail. Okay. So you should be able to understand and give me a scenario. Maybe there are other scenarios also. One scenario is what I mentioned, right? So there is a faraway chunk. So in one line, if you want to explain, there is a faraway chunk which doesn't have the object, right? So, but it talks about that object. So the object is somewhere in the three or four chunks before that. So in that case, this particular chunk independently cannot understand who is that person, right? So this happens mostly. Why? Because our token size is only 400 tokens. 400 tokens is nothing, right? If you take any document, it will be like that. Right? You can minimum a section will be more than 1000, 2000 tokens, right? So that will happen. Okay, coming to this slide, chunk size trade-off critical decision. Okay, so what is the good chunk size? In general, it's somewhere like this. Okay, so overlap you can take around 0.1 to zero point 0.2. Okay, and chunk size and overlap size is like this. So you can take 10% or 20%. Okay, so overlap is like this. But what should be a good uh, chunk size? How will you decide this? Can somebody think of a situation like not situation, not the correct word. Think of the criteria which you should use to select. Okay, I want to chunk. So here I have written 400 chunks, right? So why did I write 400 chunks? Why not 1500 or why not 5000? So I'm telling till now, okay, uh, this chunk is being missed because this is around 2000. These are all total maybe considered as 2000 chunks, right? Here's my pen. Once. Okay, so this is still here. It is 2000 chunks, and this is maybe another 400 chunks. So if I say that, okay, this complete section, the subtitle one till here is only 2400 tokens. Why not I consider this as one chunk? Why I took only 400 chunks? To discuss this much time.
Is LLM
I wanted
limitation,
to.
sir?
No,
Is there LLM
LLM, see,
limitation?
nowadays LLM, say, okay, I consider I use GBD5. GBD5. I don't know, GPT-5, I'm not sure what is the size. So consider Gemini, right? Gemini 3 is very good now. There is awesome results coming. Okay, I think it's around 2 million or 1 million. I think 1 million. 1
One
million
question,
tokens.
sir. The more
Hmm.
the context size is, the better the way can answer the question, right? But because processing will be very high, that's we agree. But if you take the self attention, it is like n to n, right? So, but the
Mhm.
more size is the context, the more more value is there, right? The processing. So
Value means what do you say? More value means
it's accuracy of retrieving the information.
accuracy. No, 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 not like that. It is not exactly correlated like that. More size is just to feed in more information, but the accuracy depends on how many layers are there, right? How many layers and how good it is in reasoning, right? So it depends on those. And so more token is only thing is it will become more delayed. Latency will be high until you have a GPU like these kind of people like Gemini or GPT-5. They will have very high and lot of GPUs at a time, right? So latency is the only issue, that is the problem which will come when you increase the uh, number of tokens, context window. But what is actually required is how much of intelligence they have put in and how much deep the model is. Deep, understand, right? Deep means how many decoders, right? How many decoders you have. So context window is this size, and these are all the decoder layers. So what I'm saying is how deep it is. This matters for intelligence. Correct, accurate answer. Okay. So if you have like 200 decoders, 200 decoder layers, then it might be good compared to 100 decoders. And also reasoning. So reasoning logics, right? So how reasoning is imbibed into this during its training process, like what we read before our mid exam, right? So how reasoning is imbibed into this model. So these two things matter for accuracy. Okay. So that is why when you go more context window, more training is required on all these things. Okay, more number of layers are required, more reasoning training is required. But only increasing the model size will not guarantee, only increasing the context size will not help. Okay. Okay.
Sir,
Yeah.
so to answer your question, I guess if we add more tokens in one chunk, then the meaning of all those tokens will be compressed into like some get it will get summarized as compared to less chunk size, and we get precise meaning of each paragraph if we put chunk size as smaller.
Mm, yeah, see, that is correct. But see, forget about LLM. Okay, so we are not talking about LLM actually. Actually, here the topic got deviated. Forget, first of all, what are we talking about is chunking, right? So, what is the next step? Immediate next step is embedding. LLM comes here. Okay, so which is this third step, fourth step, then you get all these things and then come here. So for chunking, the limitation comes from the embedding, not even from LLM. So we are talking about RAG pipeline. Okay, so it's not just we will chunk it and put it to LLM. No, that's just a simple LLM call. Okay, so that is nothing. So come out of the LLM. So now what we are trying to say, what I am trying to say here is that the embedding model. So what is an embedding model? I hope you guys know. So embedding model is something which converts your text data to a vector, right? That's an embedding model. So there is a limitation of your embedding model, right? So a good embedding model, as on date, I guess GPT-4 even had around 4 tak I know. I don't know. After that, they didn't tell. I guess 4.1 tak it was around 4096 is the vector size. Okay. But normally in our enterprise, I have worked maximum 1536. Okay. So in general, I work with 1024 size only embedding models. Okay. So forget about all the other numbers, which is not applicable. So, and even if you take any good embedding models, this will be around here only. You can get a very big embedding model. It's not like it will be good. Okay. So you can get, but then what can stop? What can there be a limit is like, for example, I am saying that 1024 I use. Okay. So there is a model I have seen which has 32,000, if I remember correctly. Yes, 32,000. 30,000 too much, I guess. I don't know whether that model is still there or not. 8,096. Okay. 8,096 was one of the model. So now tell me, so now chunk size, what I'm trying to say, chunk size depends on, okay, proportional some logic with vector size. Correct? That's what I am telling. So again, vector size is dependent on something else. Everything has to be back calculated and then finally decide what is the chunk size. What could be the point? I will show you the diagram. Think. I already told you the
The
steps how you should think.
chunk size should be logically for a given context, right? I mean, if you can break down your paragraph logically, I
No, no,
think
chunk size we have already resolved. Now my question is vector size, what is it dependent on?
The
So I'm
vocabulary
saying,
size.
so chunk size, I have option of like 500, 1000, right? 1000, 5000, anything. But this will be dependent on vector size. So now vector size, I'm saying I have two options, 8096 and 2102. Which one I will choose? So I have to consider something else. What is that?
The vocabulary of the
Computation heavy.
embedding model.
It
No,
should
no.
depend on LLM, right? So
No, 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 no. Don't go to LLM. LLM is far away from what is our thought.
It's like
Vector database.
question and answer or summarization. For summarization, we can use long vector sizes, and for direct question and answer, we should use short one.
We should look into DB
No,
size
yeah,
only.
that is
We should
also
look into DB size.
what is the DB size you should see? Okay, what is your DB size? And so, like for example, what I'm talking about is all for production grade. Okay, don't think like POCs, anything is possible, but for production grade, if you go to an enterprise, you will have only options available with these things. Okay, as on date. Maybe in future there are options, but as on date, this is. So when you come to DB size, you have to see what vector database providers currently provide services to. Okay. So there are options 1024, 1536. Okay. So it will be very costly. Okay. And it will be slow. When these numbers are more, it will be slow. Okay. So it is costly as well as slow. Okay. But this will be okay. Okay means this is the best performance as on date. Lower than this will be fast, but it will become more or less. Okay. Tokens now. So if your vector database provides 1024 service in serverless or servers, okay. So then you can finalize this. So based on this, my thumb rule, personally, I consider 1024 means half of the size of 1024 makes sense for the chunks. But some people go till 1000 also. I will not say it's a thumb rule that 500 honestly I have not written anywhere. It's a my personal experience. So if vector size you are using is 1024, then go for 500. If you have so much money, your and a vector database also provider also in future they are giving 8096 as the vector database services option, then you can go for this and maybe you can go for 5000 also, 4000 to 5000 or maybe 8000 also chunks. So in that time you can go for a bigger sections into it. But still, if you understand before that, you should understand two things. 500 is fine, but if you go for 8096 as your vector size, and your chunk size will be very high. But point is, there will be a lot of misses during your vector search. Okay, why? Because do you understand? I guess I mentioned that during our learning of embedding, right? So you have the tokens, right? So in your chunks, so these are all the tokens. This is 512th token. This is 0th token. This is 511th token. And this is 0th token. So my chunk size is, this is my chunk. Okay. So chunk size is 512. So I pass this to an embedding model, correct? So each token gets converted into a vector of size 1024. Okay. So each vector, each token. So embedding model does that. Okay. Correct. But your embedding model's output, this happens inside. Okay. So the embedding model's output is just one vector of 1024. If somebody has worked on vector creations, you send one chunk of 512 size to a embedding model, the output is just one vector of 1024. That's called pooling. Okay. So you'll just pool it. Pool it means you will create one vector for each of the tokens. Okay. Inside the embedding model, this is your embedding model. Okay. For each token, you will create one vector, but at the end, you will average it and then give it as a one vector. So for one chunk, you give it to inside your embedding model, you get one vector. So this size is 1024. Okay. And your chunk size is number of tokens is 512. So now tell me, if you increase this size, for example, I take it to 1024, the number of tokens. So the embedding model remains same. And if you use, suppose if you keep the same embedding model, if you create the vector size is going to be 1024, correct? So point is, for every token, you consider it like one number. And it's not the right sentence. What I'm trying to say is 1024 vectors would have formed like this, correct? And you're averaging it out as one final vector for this also. Okay. So the meaning of each of the word gets lost. So it's good to have less number of tokens to create a vector so that it brings some meaning to the word in, you will have some meaning in of that word in the vector. So now you can ask, so in that case, why don't you have one token, one vector? Correct.
Yeah, that's what my question is, sir. As you said, the paragraph having 512 tokens. So why can't we? So this 512 token can directly go to the 1024 vector, right? So
Correct.
likewise, the 1024 tokens can also fit into the vector of size 1024. Then why we are saying reduce the sizes to the 512?
No. See, at the end, you are going to use only one vector now. Maybe I'm using the same number. Just remove this number 512 and then I will show you a different number. So you take suppose 300 tokens. and I increase to 600 tokens. Okay. So now 300 tokens will create 300 1024 vectors, correct? Finally, you will average that 300 numbers, 300 1024 numbers into one 1024 number vector, not number vector. Understood now?
Okay, sir. Got it.
Okay. So now if you will average 600 1024 to one vector of 1024, it will get diluted, right? Agreed.
Right, sir.
That is why it is not good to increase more. But my next question is, okay, so every word, so it's always the best option in this scenario. If you see, keep one token, don't even create chunks. So for the complete document, if I have 10,000 words tokens in the document, okay, so I create, why not I create 10,000 vectors, correct? 1024. This should make more sense, right? Not more
Vector DB
sense.
size will
It
be too
does. It
high.
will not make sense.
Yeah, it won't make sense, sir, because the overlap.
Correct.
Yeah.
Why it will not make sense is you wanted to identify sections for answering, giving it to LLM. So if you keep one token as one vector, you're even okay. There is one more disadvantage that other person told. The vector database have to have lot of vectors. Even if your vector database is very fast, uh, in that is one disadvantage. I agree. A lot of vectors will have. Suppose I have 1,000 documents like this, so it will be like thousands of 1,000 into 10,000 vectors. It will be very huge number of vectors, so it will be slow. That is one point. But second point is that uh, when you have one word one vector, like text will be one vector. Okay, for this you will have 1024 size. But when a user asks a query, they are not looking for words, right? You need, because this text word will be there in all the 10,000 documents, sorry, 1,000 documents. It doesn't make sense to search words. You have to search contexts, right? So at least few words, a few sentences should be aggregated to prepare one chunk. So for example, if I say 500 words makes one small context. Like what is it talking about? Like we always ask, right? So if I give you a very huge book of 1,000 pages, the first and foremost thing what we see, we read it, we read the summary of it, right? So I understand what is it talking about, right? So it's that. So you, so like for example, I wanted to, I have this JNA books, right? So when I wanted to look into it, I just open up and then read the sections, just get an idea. I don't see words, I see sections, right? Search for. So if you say 512 words is a good amount of uh, word chunk, word what do you call, word cloud or word chunk. That's a chunk is better. Chunk to understand, okay, what is it talking about in that area, right? So this will be a good amount of tokens to identify, okay, this part of the document is talking about something which is relevant to the user's query. So now let me look up this complete part. Okay, so that is why you should have some amount, but if you get so much big, then it will get diluted. You'll not be able to find the correct place where we are talking about. Okay, so that's the medium. I hope I made it clear. Did I confuse or was it clear?
It's clear now, sir.
Clear. Okay. Okay. Thanks. Okay. So coming back to vector data, coming to the next step. So this is the embedding model. Okay. Embedding model is we discussed. You can read through all these topics. So next is the vector database. So it's talking about there are some vector database already available. Quadrant is there. Okay. Quadrant, all the paid also this option is there. So all the options are there. Like currently, we have also used PG vector. Postgres, it's already inbuilt. Uh, BM25 is also there in this. Okay. So we are talking about both PG vector and that is BM25 is TS vector. So you have to enable these two vectors in Postgres. Pinecone also used, Quadrant also we have used. Pinecone is also very fast. Again 1024 serverless is very good. Pod is there are pods. Okay, you can use pods so that it will be like you can have I think 4 million vectors of 1024. If you go for a higher size of 1536, then you can go for I think 2.5 million or something. This can go to 4 million one pod. So cost wise I'm talking about. Okay. So whatever and then Azure search is there also, is also good. It's also good. I have used all these things, not good or bad. Others are also good maybe. I've used this only for POCs, but this one is good for AWS if you are using. Uh, Azure, this is there, or you can go for Pinecone if you are not satisfied with Azure. Azure, it is very good. Only thing is Azure AI search. I think you have to go for a particular type of embedding. If I'm not wrong, I'm not sure about that. The embedding models are limited. You cannot use your own embedding model. But Pinecone, it's like open for any embedding models you can use. PG Vector also you can use your own embedding models. So you can self-host the model and then use it as per requirement. Okay. So embedding models we already discussed. Okay, in the previous this one, just that I wanted to show you here. So here this is the three large text embedding. This is by OpenAI. I think this is only available in the Azure AI search. 3, 2, and 1 also is available, I guess. So it's 30272. Adjustable means you can come down to 1024 also. And this is the maximum. But normally we don't use this one 3072 because it is quite slow. So maybe it depends on the technology developments also. As per my experience, thing I worked 1 year before was slow that time. So we used to go for 1024 only, but speed is fine. And but that doesn't always help. But because of this, don't go increase your chunk size also. Okay. Don't, okay, my vector dimension is 3074. So let me increase chunk size to 1500. Don't do that until otherwise it is mandatorily required. Okay. So keep a chunk size of around 500 to 1000 only. Don't go more than that until otherwise you are okay with very um, high level searches. Okay. Uh, okay. So now coming to the advanced RAG. So naive RAG, that's what we have seen, right? So this is in the indexing time. So documents, you will do an indexing and keep it. This is your vector DB. Okay. And during real time, your user sends a query. So you go to the retrieval process. Retrieval process sends the query to your vector DB and then gets some context. So you'll get some context. Okay. So this is your query. Then both query and context will go to a LLM where you will write some system prompt. Okay. System prompt. So you'll add this plus this. Three things will go to your LLM and LLM will generate an answer. Okay. So it's a very simple stuff. Coming to the advanced one. Okay, advanced one, we'll see now. So let me know if I'm not clear somewhere. Okay. So advanced one, we are not considering other part. In real time means query time. Query time logics, we are changing few things. Okay. So this is the indexing pipeline. So that we are not changing as of now. You can change that, again depends on what is the kind of chunking, what is the kind of embedding model you want to use. And also one thing, it's an out of syllabus, but still I'll tell, do fine tune embedding models. Okay. It's very, very important. I ask this question when I interview. If you can't fine tune embedding model, it's not you can't. I'm telling you the fact. If you fine tune your embedding model with your this one, what do you call with your domain data, 10 to 15% improvement in your accuracy. Very, very important. So 10 to 15% is huge. Okay. So you will get around 60 to 70 normally without doing anything. Okay. If you will, it again depends on what is the embedding model you use. If you're very having lot of money, you can use a very high level embedding model. But if you are intelligent enough and to reduce the cost, you take a general like smaller embedding models. Like for example, you can take BG or something. Okay, BG or any other embedding model. I'm not biased on anything. So you can take. I'll not write the name. Oh, becomes biased. Okay. So take any normal embedding model. No need to go for a high quality embedding model or costly. So embedding models are also services are provided, right? So like this, A services are there, right? So here there is an embedding model also. So which is hosted. This one, this is hosted. I think. This open source. I don't know. I don't think this is open source. This is costly. Okay. This is the BG what I was talking about. This is costly. I think this is also costly. Okay. These are all free. This one is free. This is also you have to pay. These are all costly, but if you wanted to save money, you can take something like BG or Almini. Almini is too much low, but take BG. Okay. So in that case, I have to be biased. Okay, take BG and then if you fine tuning embedding model. This is very, 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 very important. If you don't do this, if you do not know how to do this, you don't qualify yourself as a GenAI scientist. Okay. So this will minimum increase 10%. That's what I can guarantee. Every chatbot I have done. Okay. So because this is a huge improvement, 10%, 70 to 80 we reach easily doing nothing except that initial training, technical domain words. Very, very important. Even I'm not saying that okay, if you use a costly embedding model, it will work. No. Many of the times, even this, I think we used two, I guess. This also did not work. But when we took this, it also didn't work. But when we did a fine tuning, it worked awesome. Okay, not awesome, it's 10% plus. We could not fine tune, but this one, because this is proprietary, right? But there might be option to fine tune this also with your domain data. Nowadays, fine tuning is not a big work, but you should think that, okay, you should do. Okay, it's not a big work, but you should know that you should do it. What I said, you should know. That much at least you should know. Fine tuning, like how to do, you don't need to know because there are many platforms you can just upload the model and upload the data and it will fine tune and give. Okay, you have to pay some money for some few hours, maybe their GPU cost, but do that fine tuning because you need a good accuracy. Okay. So that's one very important thing, useful. After this coming to, so in advanced like here, what we are talking about, see, it's not like advanced means it's latest, but just that it was a name which I had given. Okay. So you can have query routing. Query routing means you identify what is the query asked for. Like, for example, you have a document database, document system, and you have a database system. Okay. And suppose if you have a graph database. So this goes to vector DB. Okay. Vector DB. This also you will chunk it and go to vector DB. Oh, no, you don't need to send this to vector DB until otherwise you wanted it. Okay. So you can have a SQL DB also, this one. Okay. It's like SQL DB. Graph is you can have Cypher or whatever is the language you want. So there are three options you have, right? So your user may ask questions anywhere. So anywhere means it can be related to this, it can be related to this, it can be related to this. So if you can identify that at front end, the starting itself, it will be very easy. Otherwise, you have to search in all three places to provide an answer. It's costly, right? So why do you have to run a cipher query when you can understand that okay, this answer is going to be in your document database. Okay, and another one more thing. for folks here, because why I say this, I'll tell you. Many of the project people, they come and do that. Okay, 10 documents. So when I say a document database, I'm talking about a million document. Okay, so I'm not at all talking about 10 documents, 100 documents. And when I'm talking about a database, it is around 2000 tables with some of the around 100 tables of some 7 million rows. This is called a production system. Okay. So the numbers mean a lot. Okay. So, and a graph database means I'm at least talking about 20 million nodes. Okay. So this is the range we talk about. Okay. So why I'm saying is this is what you should be designing. If you can design these three at this levels, you will qualify to do it in 10 documents and 700 tables and nodes around 1 million. A million, the graph will increase. Okay, 1 lakh, 1 lakh. Okay. So this is very easy. Okay, these are all simple stuff. So what we are talking about, what you should learn is to do handle these. Okay. So that's what is the numbers, which I always miss in the previous semesters also I missed. And when I come to this projects review, people think that they know production systems by telling that, okay, I have reviewed 10 documents. See, if there are 10 documents reviewed, 10 documents RAG, 10 documents RAG is not at all a RAG, because I can feed this one document into LLM and take one summary and keep it. I don't need RAG at all. Okay, so very detailed summary. I'm not talking about small. So I just have to create some 10 documents like this and then search it in that. It's no need of any vector database and all. 10 documents doing any RAG is not at all a RAG. Okay. But for our assignment, of course, it will be like that, just for learning purpose. Okay. So because a lot of learners are also there, learn from here, but your aim should be, say, I'm not boasting, I'm not pushing you. Okay. What I'm trying to say is this is what is the in real life production. Okay. In production grade systems. So what I'm saying is your thought process for chunking should start when you have 1 million documents. Don't think below that. Don't think that, okay, one document you take, you see the page wise and then chunk. No, you should take 100 documents, parse like randomly, and you should be able to parse. Okay. So, and every format, chunking format, you should decide. Okay. So, format wise means what I'm saying is dot docx, dot pptx. How will you chunk each of them? If the chunking here is different from here. What we have seen in that fixed chunking will not apply everywhere same. Okay, only for docx it will apply. So pptx, how will you do? And there can be a file like md file, markdown files. There can be xlsx file, right? So csv file, and there can be what else, doc file, right? So there's a pdf file. In pdf there are two versions. One is only digital, another is scanned. Scanned means you have to use OCR, right? Digital means it just printed ones, right? So just that text will be there, text and images tables will be there. In scanned, it will be everything will be a scanned document, right? So every format you have to handle. That's how you go into productions. Okay. So it's a huge thing. It's not possible to teach everything here. But what I'm saying is who wants to go ahead, right? So whoever wants to learn more, individually you should handle. Okay. So, and whatever you are doing, like starting from your chunking, embedding model selection, vector database selection, query, all these things, query routing, query rewriting, query expansion, all these concepts should be taught in terms of how much of amount of data you are having here and here. Okay. This may not be possible if you are using just SQLDB, but for vector DB's logic, you should think about how much is the one. If it is 10 documents, don't go for RAG at all. There are very easier solution than that. But in assignment, we will ask for RAG, so you do RAG. That, oops, sorry. That you have to learn for your learning purpose. We do. POC is fine. It's fine. So production grade, again, see, I'm not saying that, okay, you in your company, you are having only 10 documents is not like, okay, that's not at all a project. No, you can go, if your company requires you to search 10 documents for a production gate solution. Yes, but RAG is not a solution there. That's what I'm trying to mean. You should go because you should do that production work, but not RAG may not be required there. You can ease in a easier way. You can do that. Think of different ways. Okay, maybe this question I can ask in exam also. So I have a
So,
5 documents.
sir,
How
just
do you
Bhagat
without
sir,
RAG? Yeah, yeah.
sorry, interrupt you. So, if for the 10 document or lower than document, what the approach you are talking about here?
I didn't talk. That's what I will ask in exam. You think of that. You
Yeah,
Okay,
told
but
I
it
sir,
is
mean,
just
RAG.
so your
You
question
find the
is that
answer.
let's suppose I have 10 documents. So, what the
Hmm,
alternate of RAG, right?
correct. High level quality. Okay, so you have to sell it to your client. Means it's production grade, right? So, but do you think RAG is the best option, or is there any other option better? 10
but sir,
documents of
if
just
the
20 pages in each document. Okay. If 10
if the
documents of
con
1000 pages, that's different. But 10 documents of 20 pages. Okay. Yeah, you tell me.
Yeah, sir, but I understand what you are saying that okay, 10 documents, very small content, we can put a high level summary and feed it at runtime. But if
No, no, no.
the
That I didn't
nature
tell
of the
full solution. First of all, I didn't
no,
tell
no,
you the
that's
full
not a full
solution.
solution. I understand, but
Uh,
if the nature of the content is highly dynamic, right, an automated solution is needed where client is only required to change a document and then uh, model adapts or application adapts. Even
mhm.
in that small content use case or 10 document or 20 documents, RAG is the solution, isn't it?
No, 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 no. Automated क्या होता है? Automated तो everything is automated. वो LLM summary क्या automated नहीं है? वो भी automated ही है. RAG is not at all a solution for the 10 documents of 10 or 20 pages. For sure, it is not. Think of a solution. That's what I am telling. Think of a solution. But everything is there in plate. You have to just think. Just RAG is like vector DB, right? So RAG means what is RAG? RAG. What I'm saying is okay. Maybe I'm not clear about RAG. RAG means
Okay.
okay. Maybe it is not exact word is not RAG, which should have used. Vector DB is not a solution. Vector
Yeah,
DB is not the
yeah, that
right
I can
solution.
agree because
Ah,
yeah, that I can agree because RAG could be very native, like where I am not storing anything into text. Maybe at runtime I'm simply reading all the 10 documents, bringing text data itself, and then generating answer on top of that. I'm
there are different ways.
looping
Yes,
out.
yes.
Yeah, I'm looping out vector DB. Yeah, that is
Correct.
acceptable.
Yeah. Yes. What I mean RAG is vector DB. Sorry for that wrong word. So what I say is don't use vector DB for 10 documents of 20 pages. Okay, very small content. So there is a better option, more accurate option. So vector DB is in fact it will dilute the answers. You will not get good answers from there. Okay. It's always good to have a more accurate solution in a very simpler way. Costly also. VectorDB is costly, right? So until otherwise you use some open source vectors like Fies or something. But that also it will you can go for this one. But there's a easier ways you can get that more accurate answers. Okay. So what we are talking about is like a lot of documents, at least 100 documents is at least required. I have some 1000 pages of each document. Okay, so that makes at least a good quantum for vector deep. So now coming to routing. Routing I already explained. Rewriting is something like so rewriting is like once you have some context, right? So for a particular query, you can mm, get some context from the backend, right? For initial search. For example, in our hierarchical chunking, we had some three levels of uh, s- uh, data, right? So one is like document level summary, Second is section summaries maybe, or section itself. Okay, second one, this is document summary. Third one is the actual chunks, the small chunks of the document. Okay, this is the actual content. So, so so for a query, you can do one thing is like directly search on the document summary table. So this will be like not so big, right? So one document, one summary, right? So if you have 100 documents, it's just 100 vectors. If you have 1 million documents, it's just 1 million rows. Not a big deal. But for 1 million documents, the chunks will be like 20 million, right? To 20 million. So 20 million searching is very difficult. That you keep it at second level. So for query rewriting, you can check for this document and then bring it. Another one is history. So one is from here you can bring documents summary. Another one is history. History means what? In the same chat. So in your in a current chat, so this is your chat window. This is the query one. You will get a response one. So query two, when you are asking, you have to rewrite the query at the back end. You don't need to show it to the user. Okay. So rewriting means you are rewriting it inside your pipeline. Okay. So you don't need to show that to here, because query two mostly will be related to response one and query one, right? Because it will be a follow-up query, right? So for example, I ask what are all the types of vector database. Okay. So in the response, it says, okay, first is dense one, second is vector sparse, third is graph. So in the second query, I'm asking, okay, explain me the third one. Okay. So that query is not self-sufficient, right? So the user has asked, explain me the third one. What is that? Without any context. But until you take these two information, wherein the third part of this answer is graph, right? Graph DB. So now if you rewrite, the rewritten query 2 will be like, okay, explain me the graph DB, which is the third one of the previous question, right? So that kind of rewriting is what we are expecting. Okay, that is from the history. Apart from that, you can also take some context from your database to understand, okay, how to rewrite. Okay, so you can rewrite in a better form. This is more useful for technical domain. Okay, this part, history and document summary. This one is the query expansion. Query expansion is also part of rewriting. You can do an expansion of, you can give a system prompt also, or you can do this kind of, you can have one more repository where you can have abbreviations. It depends on your use case here. So for example, in your when you are parsing through all the documents, you can also extract all the abbreviations and keep. And for the given query by the user, you can go see the abbreviations, maybe in a vector form or in a keyword search form, and then bring those and then expand your query so that you are able to bring in more context to your query. Okay, before you go for a full-fledged vector retrieval. So at this place only, it is full-fledged vector retrieval, not a vector DB's retrieval. Okay, so here you will go. So your the query at this point will be completely enhanced. Okay, this query is different from this query 2, okay, which came from user. Query 2 came from user, but this two query 2 B I call is very contextful information, because when you give more rich query, then your search also will be more logical and bring in good quality chunks from this retrieval. Okay, so now you can use this chunk, full chunk table. This table you will search, right? You do the vector search here. You can also do dense vector search as well as sparse vector search. Okay, so this is vector search means you can have either both or it's one, any one, and then bring the chunks here. So now you can use this query 2 B plus these chunks which you brought in. Now we can see what else we can do. So one thing is that when you bring it with the dense vector and then sparse vector, you have to do a re-ranking, right? So not only re-ranking, you have to do a RRF actually, which I think we studied, right? So if you use dense vector and then you use sparse vector, you use RRF, and then you bring the final chunks. Like here 25 you brought, here you brought 25 chunks. So after RF, you maybe you bring only 10 chunks. Okay. So the 10 chunks go here. Okay. So this is this 10 I am talking about. So now coming to re-ranker. Re-ranker is something like, so I hope you guys know about re-ranker, right? So re-ranker is, do you know? Did I teach actually? I forgot whether I taught or not. Did we
No,
teach
sir.
about no, right? Okay.
Yes, RRF we read.
RRF is different. Okay, RRF is reciprocal ranking fusion, but re-ranker is different. Re-ranker, what we does? Okay, what it does is, this will answer some part of the previous question what I was asking about the without rack system. But I give you a tip here. Think about it. But okay, I will not discuss that answer now. That's you should think. Okay. So re-ranking. So here what I'm talking about re-ranking is, if there is a model here, this is an embedding model. Okay. So there is two kinds of re-rankers. One is the cross re-rankers and another is by encoders. Okay. By encoder and cross re-ranker. Okay, we'll talk about cross re-ranker first. Okay. So what it does, I'll tell you in a, I'll not confuse. Oops, what happened? Okay. What it does is it will take the query and one context. So we have 10 context, right? So what we got? So we'll take one query and one context. So queries tokens are there, correct? These are all the query tokens. These are all the context tokens. Okay. So now it will create one vector out of this. Okay. And not one vector, it will create one score out of it. The model, this is the re-ranker model. Okay, this is called cross encoder re-ranker. Okay, cross encoder means, so when you are sending it, this is an encoder block. So what happens is you are merging this and this, all the tokens, you are sending it as a single input to the model. And what happens is it will do a cross, right? So that is what is attention layer, right? Attention layer does this cross, right? So and then final output is a score. Okay, so each token of this is interacting with each of the other tokens in the query. This is cross encoder. Okay. There is one more logic what we other we use, but that is not so good, but people use it. Okay, that is by encoder. Yeah, by encoder cross re-rankers. Okay, but this is the good way, but it is slow. This one is slow. To make it faster, you can use this logic. Okay. And this logic will work for this logic what I was asking for. Okay. This is one model. This is one model. This is one encoder. This is encoder 2, encoder 1. You send the query here. You send the context here. But this is one stuff, right? So for showing it outside, it is like this. But inside, it will do only one. So here, encoder is separate. Encoder is separate. So you send to the complete system, you send the query and the context. Okay, same like here, but context one. But here, what it does is it goes, query goes through one encoder, chunk goes through another encoder. It creates one vector. It creates one vector. Okay, this is query vector and this is context vector. Okay, and then it will create a cosine similarity of both and then give you a score. So point is every chunk will be combined with a query and then brought a score. Same here. So this also will give you a score. This also will give you a score. But you should choose logically this one. Why not this one? Can somebody tell why we should logically choose this one, not this? Did you understand this and this difference? This is one full encoder. Okay, this one full encoder. in which the tokens are being cross attended, okay, by the attention layer. Inside this cross attention is there here also, okay. But here the query is sent inside and you get a vector, and chunk is sent inside and you get a vector. And finally you do a cosine similarity and then get a score. There's a huge difference between this and this. Do you agree? Understood or not? Did I confuse? Okay.
Yes, sir, it is understood.
Understood. Okay, thanks. Okay. So point is this is slow, but you should go for this. Why?
It will capture the context better between query and content.
Correct. That is correct. Correct answer. That is yeah. First correct answer is this one. There is one more point, which is like very funny point. Why you should not use by encode. But your point is the most important point. If somebody asks you, this only you should answer. But there is one more funny point in the RAG system. What is RAG means vector database system. I always call it as RAG. Sorry, vector database system, because your vector database dense vector logic is this. Agreed? Vector database dense vector does exactly this.
The same, yes.
Correct. So you are repeating that, right? So this score is already available to you when you got this 25 chunks from your vector database search. So you are repeating that. It doesn't make any sense to apply this. But when you can apply is this point. I have told the answer, but you can think of this. Okay. Okay. So no problem. That is out of the RAG, which I was talking about. You don't use RAG. Okay. Okay, now coming to this point. So you have to use this cross encoder, okay? But cross encoder is slow, and that is why we use it at the re-rank, post retrieval, okay? So ideally, if you see, the best way of finding the right chunk is this one, cross encoder, okay? Using this vector database is not at all a good stuff, okay? But why we are doing vector databases? Because we are doing production grade, this one or this. Now the answer, I would have answered the question what I was telling. If there is 10 documents and 20 pages, you don't need vector database, because in this case, I'm saying that this is the best option, right? Why we are not doing this? Because it is slow. And why it is slow? Because I am using 1 million documents. I cannot do this slow checks for each query. It's like I take a query, I go to each page of my document and read this parse through and then find. So how much time I am going to take for 1 million documents? It's very difficult, right? But if for 10 documents, I can just parse through maybe a minute in a very fast, because computer is fast, right? So maybe humans you will take more time, but computer will do fast search. So it is very good, very, very good. This is accuracy is awesome here. So for few documents, this is the only way. Okay. But when you have 1 million documents, you cannot take all the chunks. Like I was talking about, like 1 million documents means you will have 20 million chunks, right? So 20 million chunks, you cannot do this cross encoder logic. The client will leave the place, right? Before the query is answered. So what do? We are filtering using a less accurate way of search. Okay. So we are filtering 25 chunks. We are filtering 25 dense one. Finally, we are filtering to 10. It's not a standard number. Don't go by this. You can take 20 also here, 30 also here, 50 also here. Okay. It depends on what is the logic. And it is not a constant number also. Another thing. So don't go by number here. The right way is to go by the score of the RRRF. Okay, score. I hope you understand already what is a score. Go by score so that it is not a constant number. It should be a variable, adaptive number. Okay, so go by a score. It can be like minimum you can keep 3, maximum you can set. The range you set, but go by a score. Okay, that is the most right way to go for production. Okay, because some questions will be limited to a one document. Some question requires some 10 documents. Okay, so have that privilege, have that logic. So coming back, what I was telling. Okay, so we have filtered, right? So once you get the 10 documents, now this is like less accurate way of search, right? So now you finalize 10 documents. Now I will go for a re-rank. That is thorough checking, right? So very high level checking you do with this 10 documents, and then finalize what is the final chunks. Maybe 10 documents came from here. So after re-ranking, I say that, okay, maybe 4 documents is sufficient for me, which is actually having the query relationship. Okay. So I hope I'm clear here, right? This is where you are actually using the attention mechanism to get the relationship between query and chunk, but it is a very slow process because of that O n square. I hope you all know that. Okay. Okay, and then you can do fusion, summary. There are a lot of things. Summary is you can compress these 4 chunks if at all you want. Okay, so it's not mandatory, but you can do. Like for example, this is 4 chunks is easy, but for example, if you say in this one it came around 20 chunks. Suppose you set that 20 and 20 came, and when you do a re-ranking, it came 15. Okay, so at this point 15 chunks came. So at this point 20 and this point 15. So what happens is 15 chunks is too much for a LLM. Not too much. If you use GPT and all nowadays, it is not too much. But in earlier time, it was too much. Also, if you use an open source LLM, which has 8,000 tokens, for that it will be too much. So what you can do is you can summarize that, not send all 15 here. Again, send one document, one chunk to LLM here. Okay, and then one chunk to LLM, and then compress it based on the query. What is the actual content of the chunk which is required to be captured, extracted? Okay, so like that 15 chunks you will send it to a small LLM along with the query, and then take only that relevant part of that, and then accumulate it like 15 data points. Okay, and then finally that 15 data points along with your query you send, you will get the answer. Okay, fusion is something like fusion is like if your chunk is this is your document. Okay, so if your chunk is chunk 1, chunk 2, chunk 3. So if your retrieval and re-ranking, you understand that chunk 2, chunk 3 are retrieved, then you can fusion this as one part, one section, and then send it to this final LLM. So otherwise, what happens when it comes from this RRF and re-ranking, all these are shuffled, right? So it may be like C3 and C2, or maybe this is document 1, right? So I'm talking about document 2 also. There is a maybe chunk 4, chunk 5, chunk 6, for example. So what happens when you are doing re-ranking and all those things? Finally, the chunk order will come like based on the score you will do, right? Based on the score, you will do a re-ranking. What happens is this chunk 5 will come first, and then this chunk 3 will come. Maybe chunk 2 is here. Okay, and then chunk 6 is here. Okay, so this is from second document, this is from second document, these two are from first document. So the order is like this. This is not good, right? So you have to read order because chunk 3 has to follow chunk 2. Chunk 6 has to follow chunk 5. So you have to reorder that. Reorder and fusioning based on the documents. Okay. So that is very important before you send it to LLM, because that flow has to be seen by the LLM in the way it is there in the document. I hope I explained all the things. So the rest of things will be very easy. Okay. I hope everything is understood, right? Is it fine?
So just one question.
Yeah.
For embedding, we use one model, and for query as well, can we use a different model for a query, rather richer than what we did to embed the documents? Is that a
What is
standard
query?
practice? So for a query, can we, the query also needs to be vectorized or embedded, right?
Mm-hmm.
To match the score. So can we use one model for document processing and persisting in database, and other model for user query, like two different embedding
Mm.
models? Yeah. Is
No,
that
no,
the
no, no,
standard
no.
practice? No. Okay.
No, no, no. How will you use a different See, every embedding model is different. It will produce a different type of vectors, right? Different vectors, not different type, different vectors. Even though the size may be same, but vectors are different. You cannot use a
Okay.
different vectors. You should use the same embedding model.
Okay.
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 So if you are
Okay.
using, understood, no, it is compulsory.
Yes.
It's not
Okay.
like an option. Yeah.
Okay. Okay. And the
Sir,
other
No,
question, sir,
one more
I
question.
can.
Yeah,
Yeah,
go
yeah,
ahead,
yeah.
please.
Let him
no,
finish.
other,
Yeah.
yeah, other question I had, this something like a metadata. Can we use that in for RAG, just more information to store, like meta information for every chunk to be stored so that it can be queried efficiently or something like that?
Yes, yes, yeah, you can also do that. It is very important when you go for lot number of documents and the queries, right? Yes, metadata has to
Okay.
be chunked. Not chunked, there
Okay.
is a different way of metadata handling. Metadata search होता है. This logic
Okay.
itself will change the complete thing. So it will not be part of your text. It will be along with your chunk, but you can do it in either way. You can do it in a structured way, metadata search, or you can use it in a vector based search also in vector metadata. It depends on
Okay.
how you want to do. Understood.
Okay. 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 Thank you,
Mm.
sir.
Mm. Yeah.
Sir, one question I had, a little bit confusion. You
Mm-hmm.
mentioned that uh, fine-tuning the embedding model is very important
Mm-hmm.
on a domain-specific data. So
Mm,
I'm just
correct.
trying to relate, when we pre-train our model, it must have used the embedding model. And if we are also using the same embedding model for chunk embedding, but if we are fine-tuning it, it will change the vector representation of the same tokens, right? So will it, I mean, how model learning will be impacted by that? Because the vector representation has changed, right? After fine tuning, isn't so little bit confusion over there actually I have. Did I make sense?
No, your question is actually big, actually. Like, not the question, the answer to your question is big. That's why I'm thinking whether to answer or not.
Yeah, but
Okay.
वो थोड़ा confusion है. That's very confusion क्योंकि हम we
Uh,
use one embedding model and all those vector representations were learned by the model and parameters. Now we are fine tuning the embedding model. The vector representation will change, right? So
no, no, no. I didn't understand this point. Actually, there is some confusion for you. See,
yeah.
there is a embedding model, right? There's an embedding model. Okay. So you pull from Hugging Face or anywhere, you send a text to that, right? So suppose you have a document text of 1,000 texts. Okay. You send to that, and then you will create a 1,000 vectors. So this is what you are telling. You have used the embedding model,
I'm
correct? Am I
comparing
right?
this, yeah, I'm comparing this with the pre-training of the model also. There we
Who
would have used the
pre-trained?
same embedding model, no?
No, no. Who pre-trained?
Let's take a pre-trained model which is freely available, open source pre-trained model, if we take.
Uh-huh. Correct. So this is that's what I'm telling. This embedding model is pre-trained. That's what you're pulling it from Hugging Face, right? So Hugging Face, what you're pulling? So you're pulling a pre-trained model. So whenever I say model, that is pre-trained by somebody else. Correct?
Okay, so yeah, maybe I
So you're
confused you.
pulling the
Second
model.
part, second part, the pre-trained model I'm referring to is the large language model, which is responsible for generating the responses. That would have
Okay.
trained also, that would have been trained also on embeddings, right? Generated by the same embedding model, correct?
No, 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 no. How
Not
this will
necessary.
be related to that? No, this is a different model. This see, that is
Okay,
what we studied, right? There is an embedding model, there is a decoder model, there's an encoder model, right? Embedding model is an encoder model, right? This is different
right.
from decoder model. Decoder model nahi hai, wo LLM, what we call LLM is a decoder. So
Yeah.
this is a decoder type of, right? This is LLM. This is nowhere related. There is no relationship between these two. This is a different model. This is a different model. Same company can produce this model as well as this one. This is only encoder blocks are there. In this, only decoder blocks are there. You can have
Oh,
another LLM. You can have another LLM like T5, okay, which has both encoder and decoder. Okay, but that is single, that is inside this. If this is the LLM, encoder and decoder is inside this. From this, you cannot create, for this, you cannot create embeddings. Embedding is a different model. This embedding, this encoder is inside this. So if you pass your text here, it will not give you an embedding. This will give you a response. Like it will, you pass a text here, it will give a response. This is LLM. This is LLM. Okay. So here, if you pass a text, it will give a vector. Understood?
yes,
Clear?
sir. Yeah, yeah.
Okay,
Thank you.
this is different. This is a different model. This is a different model. Okay. Okay. It's not like you, even if you take from OpenAI, both the models, maybe OpenAI has this text embedding model 3, right? I told you. And OpenAI has GPT-5, this one. Those two are different. It is not related to both. Maybe the same data is used for training this as well as training this. But what I was telling there is your data was not never used by them, right? So your data, I'm talking about technical domain. If it is like HR or something, which will be too much general, like GPT will understand by default. But technical domain documents, it will always have a difference. This embedding model, while pre-training, they would have done a good amount of documents. They would have used a good amount of documents to train it, but those will be general document because your company, your technical document, I belong to a technical company, so technical company documentation is not easily available. The words you, nobody will understand even outside until you are an engineer in these firms, right? You're a technical, like mechanical, core mechanical documentation, right? So those kind of documentation or electrical document or technical documentation I'm talking about. General English, it will be able to understand. To make this more more intelligent, you train it. So this pre-training has been done already. Yeah, this pre-training was done with a general document. So when this model will be here, embedding model, they would have done the pre-training. General documents. Okay. So that's what it is trained, and loss function, everything they would have applied and then trained. Okay. So, and then they will load it to Hugging Face. So it is there. Now you are pulling this Hugging Face model here. So this knows all the general documentation, but your technical document is like mechanical or electric, hardcore technical. I'm not talking about automobile engineering. Hardcore technical, or even automobile engineering, a lot of technical terms are there. So a lot of hardcore technical knowledge, if you finance also. So it's like how much I know finance, but if you go and talk to a manager, they will talk lot of technical terms, right? They will talk debt. Like for before 10 years back, I never understood what is a debt, what is a credit. I always get confused in that bank statement. Okay, so but the bank managers, they know, even with their 3 years, 4 years experience. That is the part I am talking about as technical parts. So those kind of technical terms, you have to train your embedding model so that this becomes more intelligent towards your use case. So once you finish the training, then you send this document to create your vectors. Okay. I hope I made it clear there.
Thank you, sir.
Okay. Yeah. Oh my God. It's quite deep. Chalo, we'll see. I think mostly covered. I think self rag and corrective rag is there. Adaptive rag. We have added many things. Okay, we'll see next class. Okay. I don't want to put so much pressure. These are all important. And yes, go see one thing I want to say, go through till here because in quiz everything will be there. Okay. Even if I didn't teach, it's not a big thing. It will be almost from here only. But think little bit. I don't know what questions is there. I am not preparing questions this time. Okay. So
Bhagat
most
sir,
probably
one
it will be.
request to you. So whatever insight you are giving about the internals of RAG, it's very helpful. So initially, as you said that if your document is having text and images also, that time those chunking mechanism will not work. And again, you have given many example which are documents that were having CSV information or tabular data. So it would be very helpful as you have worked on some many real time projects. So can you guide us that if your document is having this kind of a data, then how you should chunk, how what approach you should take to get a correct embedding model, and what options we can use for retrieval and so on, maybe from your real time experience. And maybe I understand this is not part of our syllabus, so maybe we can take extra classes for the for the same. It would be very helpful, sir, because all over the industry it's rag only rag.
Yes, yes. पैसा चाहिए पैसा. Just joking. Yeah, so it's a huge knowledge actually. Working on production and all these formats and handling. Yes, I'll be happy to share, but not during the class. Some things I explained already, but a few things I explained here, which is out of the syllabus actually. But some of them, yes, I agree. If you are interested, I wanted only the interested people. You can ping me separately if you have a specific use case, right? So some of them ping already. So you can ping me in Teams with particular queries, or I may not be able to spend time. In fact, too much busy this time. Not busy, not even having time for family. You can understand, right? So 5 days I'm in office and 2 days in bits. In fact, I was working till this half an hour before this class. So too much of work. So I'll try to find some time, but I will prefer if you like. I always love to uh, see challenge, like solve challenges. Okay, that is one point. To be honest, I'm telling. Don't get offended that I'm not able to spend time. I can give you advice like for a particular use case, like you are solving something and you are stuck up. Okay. So that particular scenario, you can ping me. I will also be happy to work on it and think about it. And based on my experience, if I can tell some solution, I can tell specific problem. If you are generally teach it, that's very difficult. Sorry for that. Okay. I hope you understand. I don't have time for my family. Really, the truth. I'm not saying that not for money or something, but sure, if you have a specific scenarios wherein you wanted a particular, you're stuck with some like iske baad chal nahi raha hai, or you're stuck with some accuracy point or latency point. Yes, I can surely help that. I will also learn there, right? So I also have an advantage of learning. Okay, this scenario is happening in so and so industry, so it'll be useful for if I solve, or I can also talk about it. It'll help me also to quote it in classes, right? So I do learn from that. So
Okay,
it'll
sir, I
be
will ping you separately.
okay. So particular situations you said, I will surely discuss on it. Okay. So sorry for the other deny. I never deny, but really I'm stuck up now. so much work.
No problem, sir. I
Okay.
can understand.
Yeah, sure. Okay. Thanks, guys. We'll see you next. Stop recording.